Okay, today we are discussing about motion of connected bodies. So this is motion of connected bodies. Okay, so we can solve the problems of this type in a very simple and shortcut methods. Let us see the first example. Here I am considering one table, and here I am considering one pulley. So this is a pulley. Let us imagine that there is one block here, and this block is resting on the table. There is another block which is hanging down. Okay, so this is block of mass m1, this is block of mass m2. I am considering these two blocks, one is hanging and one is resting on the table. Okay, so let us discuss here what is going to happen. This is going to be resting on the table and this is going to be hanging on the table. Okay, so I am going to discuss a method which is very simple and easy. Let us consider this is mass m1. So what is the force which is acting downwards? Definitely it is m1g which is acting downwards. Okay, next, what is the force which is acting upwards? Definitely tension T is acting upwards. And you know that this body will slide down with an acceleration A, this body will slide right side with an acceleration A. Okay, so you know that according to Newton's second law, resultant force will be in this direction here, downwards. Why is it so? Okay, the reason behind that is, if two forces are acting on a body, then also body is moving down, means what is the meaning here? Okay, acceleration is downwards, means what is the meaning here? The meaning here is m1g dominates tension T. m1g dominates tension T. That's the reason why this block is moving downwards. So how are you going to solve this problem here? Let us consider there is one block here. I am going to consider one block of mass m2 here. See, this is m2. Let us imagine m2 is 7 kg. I am taking one example also so that it is very clear to understand. Let us consider there is one more block of mass m1 whose mass is considered to be 3 kgs here. Okay, so this is a block of mass 3 kg and this is block of mass 7 kg here. Okay, then what is going to happen? Let us see. Here m1g dominates tension T here. That's the reason why the block is coming down. Okay, so now what are you going to do here? So we'll take the formula for resultant force here. So what is the resultant force here? Resultant force is nothing but, as m1g is dominating tension, resultant force will become m1g minus tension T here. So resultant force is going to become m1g minus tension T here, and resultant force is m1a. According to Newton's second law, Fr is equal to m1 into a. So this is going to be m1g minus tension T here. Okay, let us imagine this to be an equation number 1. Okay, so let us take a free body diagram. Okay, so let us take a block of mass m2 and how many forces are acting on that. So I am taking one block of mass m2 which is resting on the table. On this block right side there is one force acting. What is that force acting right side? That is taken as tension T is. And this block is moving right side with an acceleration A. Okay, so there are two more forces which is taken as normal reaction acting upwards. m2g is acting downwards, but these two are going to cancel here. So we will not consider these two forces even though they are present, because they are equal and opposite. Action is always equal and opposite to the reaction. That's why this is going to be an action. Weight of the block is going to be an action and normal reaction is going to be a reaction. So therefore, what is the formula going to write now? So we will write T is going to be equal to m1 into A. So let us consider this as an equation number 2. Okay, so let me draw separately and make one small separate equation here. So this is going to be equation number 1 and this is going to be equation number 2 here. Okay, so once you have got these two equations, then we can find out acceleration of a block here. So how are you going to find out the acceleration of a block? So here we'll discuss how to find out an acceleration of a block. To find out an acceleration of a block, what are you going to do here? A simple thing is, you will substitute 2 second equation in the first equation. Substitute 2 in 1. If you substitute 2 in 1, you are going to get m1 into a is equal to m1 into g. Instead of t, you will write m1 into a here. So this you will take to left side. Okay, so this you will take to left side. This is going to be m2. So therefore m2 into a. As this is the block m2 here, this is also m2. I am taking m2 here. So what I am going to do here, these two I am taking left side. Okay, so m1 plus m2 into a. Because m2 goes to left side, a is getting common. Therefore, what is left at the right side? Only m1 into j. Therefore, acceleration can be taken as m1 by m1 plus m2 into g. So we got the formula for acceleration. Okay, so as I have taken this example as m2 as 7 and m1 as 3 here, you can directly substitute and find the answer for this. So how are you going to find an answer for this? It's very simple. Acceleration is equal to m1 plus m1 first, so 3. So m1 plus m2 is going to be 3 plus 7 into g. Let us consider it to be 10 here. Okay, g is considered as 10. G is equal to 10 meter per second square. Then acceleration is going to become 30 by 10, which is equal to 3 meter per second square. So once you get an acceleration, can't you find out the tension? There are two equations to find out the tension. You can take equation number 1, you can take equation number 2 also, but it's very easy to take equation number 2 because it's a very simple equation. We can take equation number 1 also, but it becomes very complex to solve the problem. So we have to search for easy methods, not the complex methods. So now it's very simple that you just take t here and you'll write m2 here and just take it as a here. Then what are you going to get here? This implies that tension is equal to m2 is 7 and acceleration is going to be 3 here. So the answer is 21 newtons. So we got the answer as 21 newtons. That's it. Okay, so this is a very simple solution, that is 21 newtons here. Tension is 21 newtons, whereas acceleration is this one. Okay, so this is acceleration and this is going to be tension here. This is the simplest method. Okay, this is the simplest method to find out here. So we got t is equal to m2 into a. That's why m2 is going to be 7 here according to the problem, and 7 into 3, that is acceleration, is going to become 21 newtons. Okay, so this is a very simple method to understand this concept here. Okay, so let us go for the next topic here. Now, can we find out what is the resultant tension on the pulley? Yes, definitely we can find out what is the resultant tension on the pulley here, because this tension is acting in this direction, this tension is acting downward direction. Then what is going to be the resultant of these two here? So as tensions are acting here like this on the pulley, tension is acting downwards here and left side here. Okay, so this is downward tension, this is leftward tension. As there is only one single string here, tensions are going to be same. As there is only one single string here, tensions are going to be same. Then what is the resultant of these two? You can just write like this. You can just complete in the form of a parallelogram here and just write this as a tension. Okay, so this is, anyhow it is going to be 90 degrees here. This is going to be 90 degrees here. Therefore, the resultant is, according to Pythagoras theorem, you can consider the resultant to be t root 2. That's it, isn't it? Resultant to be t root 2. So answer is, what is the resultant tension acting on the pulley? Okay, so you can write like this: resultant tension on pulley, that is TR is equal to, so t square plus t square under root, therefore it is going to be root 2t. So we can write resultant tension is equal to 1.414 into, what is the value of tension? You can take the tension as 21. That's it. So whatever the answer you are getting, you just write this as the resultant tension acting on the pulley. I think you understood this one. Okay, see the next problem here. Okay, here this is the mass m1 and this is mass m2. Okay, so these two masses I am considering here, but it is clear from this that m1 is larger, m2 is smaller. So definitely m1 has to go down with an acceleration a, m2 has to move up with an acceleration a. So let us discuss about what is the free body diagram here. what is the meaning of free body diagram? First thing is, I am drawing separately M1 and I am discussing about what is a free body diagram here. Okay, so if I am discussing about a free body diagram means you have to consider this mass separately here and discuss how many forces are acting on that. It is clear that M1G is always acting downwards and tension T is always acting upwards here. As this acceleration is downwards, the resultant force is also going to be downwards only. So what is the meaning here? The meaning here is M1G is going to dominate tension T. As M1G is going to dominate tension T, the block is moving downwards. Therefore, the resultant force is the difference of these two. That is M1G minus tension T. Okay, so what is the resultant force here according to Newton's second law? It is going to be M1 into A, which is M1G minus tension T. This is going to be equation number 1 here. Okay, so once you have written equation number 1, then it is understood that we have to go for next block and we have to take the free body diagram of the next block here. So how are you going to draw the free body diagram for the next block? Next free body diagram here, and this is free body diagram for M1 mass. This is free body diagram for M2 mass. What do you mean by free body diagram? Just now I told you. So free body diagram is nothing but you have to consider the block of mass M2 separately and you have to discuss how many forces are going to act on that. So definitely it is understood from this diagram that here tension is acting upwards and M2G is acting downwards. So if you see here, acceleration is acting upwards because M1 is greater than M2 here. So it is clear from these two example that M1 is definitely greater than M2 according to the given problem. So with this it is clear that if M1 has to come down, M2 has to move up here. So resultant acceleration is upwards. That means resultant force is also going to be upwards. If you are having any doubt, I'll give one small example. You just see here. So in this direction 4 newtons acts, in this direction 2 newtons acts, then the block will move right side with a resultant force that is equal to 4 minus 2 here, that is equal to 2 newtons. So what is the meaning here? As 4 newtons dominates 2 newtons, definitely the block has to move right side, and the resultant force acting on this block is going to be 4 minus 2, that is 2 newtons. Is it clear? So I have given this example just to understand what is the meaning of free body diagram. Okay, see here in between I am telling some of the jokes. This is not to waste your time. This is to make a physics a very funny subject. Like sometimes I will tell Newton's first law. Okay, so Newton's first law we are learning, but I'm creating a new thing in that. For example, in funny way I can define Newton's first law. Every book is at rest and covered with dust. Every book is at rest and covered with dust until unless we apply some force and lift the book and read. Okay, this is a funny Newton's first law created by me. Okay, so this type of examples will create a lot of interest in the subject and it will become easier to understand here. So fun is making our brain active and enhancing our memory power. So funny examples is just to help you to remember, not to waste your time. So funny example I have given now. Funny definition of Newton's first law. Every book is at rest and covered with dust until unless we apply certain force with our hands and take it and read it. Okay, so this is a funny definition for Newton's first law, whereas the correct definition everyone knows. Every body continues its state of rest or of uniform motion in a straight line until unless it is compelled by an external force to change the state of the body. Okay, so I am very interested in rhymes also. Okay, I am interested in rhymes. This is to entertain the children while explanation. That's it, no other intention here. I'm not getting any amount by entertaining anyone. This is just to create an interest. So just let us enjoy the subject like this. Now just see here, free body diagram for mass M2. So what are you going to see here? As resultant force is acting upwards, what are you going to do now? Okay, so here resultant force is going to be tension minus M2 into G. Resultant force is equal to M2 into A, tension minus M2 into G. Here, this is considered to be equation number 2. This is considered to be equation number 2 here. So what are you going to do now? What are you going to do now? You just do one thing here. Add 1 and 2 here. This and these two equations if you add, LHS if you add, what are you going to get now? You are getting M1 plus M2 into A. LHS I am adding here. RHS if you add, T minus m2 into A, m2 into G plus here m1 into G minus tension T. Okay, I am adding this right part and this right side part here. So if you observe, you are getting that, you are seeing that something it is going to be cancelled here. What is that? So tension is getting cancelled here. So here acceleration is going to become how much here? m1 minus m2 into G. This m1 m2 comes to the denominator, that is m1 plus m2. So this is a method of finding an acceleration. It's very simple method to find an acceleration. So let us take a formula for acceleration now. You can find out acceleration by using this formula here. So once you find out an acceleration, finding tension is a very easy job here. Okay. So what is an acceleration according to this problem here? See, acceleration I am writing here. Acceleration is going to become A. m1 minus m2, that is 10 minus 2, 10 minus 6 here according to the problem. 10 minus 6 divided by 10 plus 6 into G, let us consider to be 10 here. Okay, so how much you are going to get? 10 minus 6 is 4. 4 into 10 is 40. 40 by 16 here. So 4 4 16, 4 tens 40 here. So acceleration, how much you are getting? 10 by 4 you are getting. So once you get an acceleration A is equal to 10 by 4 meter per second square, can't you substitute this acceleration in equation number 1 or 2? You can substitute here or you can substitute here. Anywhere you can substitute and you find the tension. You are getting the same answer. Doesn't matter here. So let us consider equation number 1. Then what are you going to get here? If you take equation number 1, how much it is? m1 into A is equal to m1 into G minus tension T. So let us take tension to left side here. Tension is left side here. So m1, if you common out, you'll be getting G first and minus A here. Okay. So what is tension T? What is m1? Okay, we can take m1 as 10 here. Okay, I'm finding the answer now. I'm finding the answer. So let me take tension T is equal to m1 is going to be 10, G is also going to be 10. Acceleration we just got, that is 10 by 4 here. It's very simple. Now tension is equal to 10. This is going to be 40. LCM if you take, how much you'll get? 40 minus 10. So 40 minus 10 by 4 here. So tension is going to be 10 into 40 minus 10 is going to be 30 here. So 30 by 4. Yes. So you got the answer here. That is tension is going to be 300 by 4. If you want, you can just simplify this one also and get the answer here. Okay. So you can just simplify and get the answer if you want. You can write in decimals also if you want. So this is the answer for your question here. If you want, you can keep the answer in decimals also. I think it is easy to understand, isn't it? Okay, or else you can just write in decimals also. If you divide 300 by 4, how much you are getting? 4 7s 28, 4 5s 20. So you're getting how much? You're getting 75 newtons. You can write the answer in this way also. Okay, if you want to keep the answer in terms of number, you can write like this also. This is the method for finding the tension. Hope you have understood this one. So what is the next part of the question here? We got the tension in the thread. Okay, this is going to be tension in the thread here. But we need to find out what is the tension in the pulley here already. So tension in the pulley also we have to find out. How are you going to find out the tension in the pulley? So tension on the pulley is going to be 2T here. So tension on the pulley by this thread by the string which is connected to the pulley is going to be 2T. So your answer is 2T. So with this it is clear that you can just multiply 2 with 75. It is going to be how much? 150. Okay. So tension on the pulley is going to be 2T according to our formula here. So I can write tension on the pulley is going to be 2 into 75. That is going to be 150. I think you have understood this one. It's a very simple problem. Okay. So see this next problem here. I have taken two blocks, block number 1 and block number 2. Smaller block is having a mass 2 kg. Larger block is having a mass 4 kg. And we are applying 10 newtons on these two blocks right side. So as these two blocks are in contact with each other, the larger mass will apply a smaller mass certain force here, because both combined together move. As both combined together they are moving, so larger block will apply certain force on the smaller block, which is small f, and smaller force also equally applies the certain force on the larger block, that is small f. See, small f is same on both the sides because this is action reaction forces. Okay, these are called as action reaction forces here. Action reaction forces are always going to be same. According to Newton's third law, how much force a larger block will apply on the smaller block, the same force the smaller block will apply on the larger block. Understand? That's what. So let us find out the contact force. According to the problem here, you have to find out the contact force. See, this is called as contact force, which is small m. With how much force the larger block applies on the smaller block, the same force applied on the larger block also, that is called as contact force. You can take normal reaction also between these two blocks here, or you can take contact force also. So contact force can be taken as a F, or you can also consider to be N also, doesn't matter here. So now, how are you going to find out? It's very simple here. Solution I am going to do here in a very easy method. So first of all, let us consider the smaller block, small m. Free body diagram I am explaining here. Free body diagram for smaller block here now. So what is the free body diagram? What are the forces acting on the smaller block? See, on the smaller block, normal reaction is acting upwards and mg is acting downwards, but doesn't matter, these two are going to be always cancelled here. So we need to consider which force is acting right side, that's it. So if you observe the smaller block, only one force is acting right side, that is small f here, and this is going right side with an acceleration. So both combined together move right side with an acceleration a here. Let us imagine both are combined together moving with an acceleration a. So how are you going to find out that acceleration? It's very simple. First thing is you need to find out the acceleration. If you want, you can find out acceleration directly also, or I'll tell you what is the method to find out acceleration here. So it's very simple that if a small contact force is acting on the smaller body right side, so what is that? What is that smaller force here? So that smaller force can be taken as F is equal to m into a. That's it. You got a contact force by with a simple method, that is F is equal to m into a. You can get the formula. You can find out the acceleration here. How are you going to find out an acceleration? See, acceleration is nothing but net force by net mass here. So what is the net force acting on the two blocks here? The net force acting on the two blocks is 10 newtons, and the net mass of the two blocks is going to be 2 plus 4, that is 6 newtons. So acceleration is how much here? It is going to be 10 by 6 meter per second square. We got an acceleration. If we got an acceleration, can't we find out the contact force? It is very simple. We can find out the contact force also, that is F is equal to small m, that is 2 into a, that is 10 by 6. So 1 times, this is 3 times. So contact force can be 10.3 newtons. Like this also we can find out. This is enough. Okay, so this is enough. This is the method to find out the contact force here. I think you understood. So this is the method to find out the contact force here. Okay. Next, you can also write this as 3.33 newtons also. If you want, you can write in decimal points also. So we got the contact force here, is it? So by taking one block, you have got the answer. But if you want two blocks also, if you want to find out how many forces are acting on the larger mass, actually we got an answer here, okay, directly. But if you want to find out further details, if you want to learn the more subject, let us have a larger mass here, and let us discuss how many forces are acting on the larger mass also. This is the further explanation, how many forces are acting. So you have to just learn the free body diagram here. It's very simple now. On the larger mass, if you observe, what is acting right side? Right side, 10 newtons is acting. Okay, so what is acting left side here? If you observe on the larger mass, small f is acting left side. So this is an acceleration which is acting on the larger block right side. Okay, this is an acceleration. Then how are you going to find out the resultant force? So as these two forces are acting, then also body is moving right side with a resultant force here. You can find out the resultant force acting on the left block. What is that? That is capital F minus small f. So what is the resultant force here? What is capital F? Capital F is going to be 10. And what is going to be small f? Small f, whatever we have got now, that is 10 by 3. So the resultant force acting on the larger block is considered to be 30 minus 10 by 3. This is a LCM of this. Therefore we can write resultant force is going to be 20 by 3. Okay, So we got the resultant force acting on larger block. Therefore, resultant force acting on larger block is Fr is equal to 20 by 3, or you can write in decimal points also. 6.666 you will get. You can stop it like this. So the resultant force acting on the larger block is this one. So here we can write this as the answer is 6.67. This is one model here. See here, this is another model here. Find an acceleration and tension between the two blocks. So you have to find out an acceleration of both the blocks and tension between these two blocks. That means we need to find out this tension here. Okay, so we have to find out what is the tension between these two blocks, where one block of larger mass 2m, this is another block of smaller mass m here. So let us take a solution here. We will consider the free body diagram here. We will consider the free body diagram of larger mass. How many forces are acting on that? See, capital F is acting right side, and tension is acting left side here. Okay, so as tension is acting left side here, therefore acceleration is right side and resultant force is also right side, because the total system is moving right side. So capital F dominates tension here. So capital F dominates tension. That's why the block is moving right side here. So what are you going to write the resultant force here? Resultant force is nothing but capital F minus tension T here. So capital F minus tension T. Then what is this resultant force? Resultant force is mass of the block, that is 2m, into acceleration here, that is a. So therefore this is going to be capital F minus tension T here. So let me take this as an equation number 1. It is very simple now. You can just find out the tension also. You can take a free body diagram for mass m also. We can take a free body diagram for mass small m also. So if you observe mass small m, how many forces are acting on that? That is small tension is acting right side. Nothing else is acting now. On this block, tension is acting right side. So this is going to be acceleration acting on this block right side. Okay, so this is a single mass small m having mass small m. So what is the resultant force here now? This is a free body diagram. This is a free body diagram here for mass m. So let us write the equation also here. So tension T is equal to m into a. So this is equation number 2. There are two free body diagrams we are getting. We can select any one to find the acceleration and tension also. But how are you going to find out an acceleration now? For acceleration, I will tell you one shortcut formula. What is that shortcut formula? I will tell you. So the shortcut formula here is nothing but acceleration is equal to net force by net mass here, because F is equal to ma. Therefore, you can write A is equal to F by as a general formula. But in this case, I am taking A as Fn by Mn. So very simple here. What is the net force acting on this block? This is the net force acting on this block. Let us consider this as F here. What is the net mass here? That can be considered as m plus 2m. So this can be taken as F by 3m. So we got an acceleration here. How much is an acceleration here? We got acceleration here as a is equal to F by 3m. You keep it aside now. If you keep it aside here, you can find out the tension by using these two formulas. But which is the best formula which will save your time? This is a complex formula. You will going to waste the time here. But the easiest formula is this formula. You can find out the tension by using this formula also. So that is tension is equal to m into a. Okay. So what is the tension here now? M into a. A can be taken as F by 3m. So this is going to be cancelled here. So tension, how much you are getting? F by 3 you are getting. So applied force by 3 is going to be the tension here. Okay. So I am writing the formula like this. If you convert this in the form of a question, for example, I am taking this as a question here. For example, here I am taking this as mass 1 kg. Let us imagine. Now this, as I am considering this as mass 2 kg, let us imagine. And applying a force here, let us consider this force we are applying is 30 newtons here. So if this is the case, how are you going to solve this problem here? How are you going to find out the tension? Here I'm just converting this as a problem here for an easier understanding. So tensions are acting at this middle here. You need to find out what is the tension. These both are resting on the table here. So how are you going to find out the tension here? It's very simple to find out the tension. First thing is you have to find out what is an acceleration. Acceleration is equal to net force by net mass. According to this problem, net force acting is 30 newtons and net mass is 3 here. Okay, because 2 plus 1 is going to be 3. So your answer is going to be 10 meter per second square. Now how are you going to find out the tension? So tension is equal to applied force here by, okay, applied force. How much you are getting here? Or else you can just apply this formula and do the problem. Tension is equal to m into a. Okay, so what is the tension here? Tension is equal to m into a. You can just write here m into a. What is m here? According to this problem, 1 kg, and this is 2m, so 2 kg I have taken. Just to understand, I am giving this an example. Instantly I am giving this example just to understand here. So mass small m I am considering as 1 kg, and acceleration I got it as 10 here. So tension is going to be how much? Tension is going to be how much here? That is 10 newtons. This is the answer we are getting here. Okay, so it's very simple. Hope you have understood this one.